But here in the main stage, delighted to introduce our speaker talking about accelerating AI at scale, NVIDIA AI computing by HPE. It's Patrick Couch, who's an AI evangelist at HPE, who works as an AI specialist focusing on AI and high-performance computing. Patrick, really looking forward to hearing your talk. Over to you.
All right, so thank you very much for taking the time to listen to me. I'll dig into this. We have a lot of ground to cover. So I'm sure you're all seen slides like these. AI is going to transform everything. No stone unturned in society, in industry. We're all going to be transformed. It's just that it doesn't really seem to be happening now, does it? So you've also maybe seen these kind of stats, like 1 of 10 initiatives go down the drain or succeed and the rest of them don't. So the question is, of course, why? Why are we all agreeing that AI will transform everything, but at the same time, very little is being pushed successfully out into production? And the reason for this is something that I think Elon Musk put the finger on very nicely when he was on the Joe Rogan podcast some time ago. And Joe asked him about the superintelligence, the artificially generally intelligent God that's going to magically appear out of technology and come and, take over. And then he asked, is that AI going to be bad? And Elon Musk said, no, Joe, no, it's not going to be bad. It's going to be outside of human control. And I thought that was very insightful. It's just that for most of us, the idea of the superintelligence is not a reality that we sort of pragmatically work with. We may sort of speculate about it, off office hours, but really what we are dealing with and what we are facing is something much more challenging, namely the return of this. And this is a problem. This is a challenge. For those of you old enough to have worked with the Office Assistant in the early 90s, you will know that the best feature it had was this: don't show me this tip again. Because it did not increase productivity. It was just stealing time from you. But the thing was, it only resided in your local instance of the Office package that you had, right? It could only be bad in that space. Now today, we're moving these assistants and agents outside of our locally controllable environment, and we're saying, hey, you can touch the smart home, you can touch the smart car, you can put the egg timer on, you can do different things. And we're just progressing down this path of creating ever more able assistants that can help us in the digital village in which we live. It's just that when you give the algorithms a certain amount of autonomy, you also have to deal with their behavior. And we're seeing a lot of weird behavior out there in AI space. We see the AIs crashing the cars. We see AI not being successful in recruiting people. We see AI struggling with being a fair credit scorer when you apply for your credit cards. You see various biases in terms of visual recognition and racism being played out in practical applications of AI. You see guardrails being put in, and then guardrails being co-opted and subverted, most recently by the Reddit community, which had a field day a couple of years ago. And then you see, of course, semi-autonomous agents discounting prices on tickets outside of policy. And the airline going, what's the bot doing? And of course, they try to argue that, well, the bot has to be responsible for its own actions. We're not paying those ticket prices, which was, of course, not acceptable. So when we think about this, then, I think it's worthwhile thinking about agency, ability, and autonomy and sort of see the trajectory of our technology. Where are we heading? Because if you rewind the tape 30 years ago, we were basically at the level of the AI or the technology being good at mastering rules. And we proved that out by playing chess. A couple of years later, when I was at IBM, 2011, IBM played Jeopardy with their Watson technology, which was the first time I saw machines actually parsing language quite successfully. And that was a watershed moment. I thought the new millennium was going to happen then, but it took a few more years. Then, of course, Google DeepMind showed that you could also iterate your way into new insights, and they can come up with completely new strategies of executing a game plan successfully. And we also saw that you could actually have algorithms learn how to collaborate. And humans often sort of pride ourselves in the fact that we are the dominant species on the planet because we're the best at collaborating. So one human against one tiger, not a good matchup for the humans. Enough tigers against enough humans, the humans win, right? Now we're showing that algorithms is actually, they're pretty good at collaborating as well. And of course, already 2016, when Google Duplex was announced, it was shown that speech is also something that they master. And speech is not language, it's not the same thing. Speech is something much more intimate. And we'll see what kind of phishing emails we're going to be having the upcoming time. And then we're moving also now into the space where we can see the early signs of reasoning being able. And IBM proved this out already in 2017, 2016, when I was there, and we did Project Debater, and we could train a neural network to master debate. And what is interesting with debates are they're not about being right. It's not a single point of truth being conveyed in a debate. The debate is about persuasion. It's about seduction. It's about seducing you to adopt my point of view. And we could see that Project Debater was successfully doing that. And of course, today we're in this tremendously exciting time of generative AI. And you can have everything generated, you know, your code, but also your artwork. And most recently, the guys over at OpenAI dropped the strawberry model, the reasoning model. And at some point, we're sort of seeing a trend here. What is the trend? Well, the trend is something inversely true of what Ludwig pointed out in the 60s when he said, people are not machines, but in all situations where they are given the opportunity, they will act like machines. And basically, he was making the point that humans are lazy. The brain is an energy conservative mechanism of some sort, and it doesn't want to have an existential crisis every morning whether or not it should brush its teeth. Now, my 5-year-old son, he can have an existential crisis every morning. And I tell him every morning, we're going to brush the teeth every morning. Still an existential crisis every morning. Most of us, we just brush our teeth and off we go. So we're sort of energy preserving. We're just automating certain behaviors. Now, what I have noticed, having been in this field of AI for the past 20 years, is machines are not people, but in all situations where they are given the opportunity, they will act like people. And thus they will drive our cars and they will crash our cars. So that leads us to the human factor and stupidity. And a lot of people in AI space, they don't talk about stupidity enough. I love to talk about stupidity because I think A, it's funny, and B, it's actually instructional. And to help me with this, there was a guy called Carlos Chipolla. He was a professor at Berkeley, and he wrote a fantastic essay called The Basic Laws of Human Stupidity. And he put a fantastic diagram up. And he said, if you behave in a way that is good for you and good for others, congratulations, you win, you are intelligent. But if you act in a way that is bad for you, bad for others, you're stupid. And then he said you can act in a way that is good for you at the cost of others, then you're a bandit. And then the inverse, then you're sort of a helpless person. And with this in mind, and this is just a purely behavioristic view of things, with this he said, there are 5 basic laws of human stupidity. Number 1, always and inevitably, everyone underestimates the number of stupid individuals in circulation. There are a lot of stupid people out there. 2, the probability that a certain person will be stupid is independent of any other characteristic of that person. Women are not more stupid than men or any other variable. It doesn't matter. The definition of what a stupid person is. Non-stupid people always underestimate the damaging power of stupid individuals. In particular, non-stupid people constantly forget that at all times and places and under any circumstances, to deal and or associate with stupid people always turns out to be a costly mistake. Don't associate with them. And finally, a stupid person is the most dangerous kind of person. And when I saw this, I was like, that's exactly true of AI when you put it into production. Because once you go into production mode, deployment mode, you are having AI behave in the digital space. And then if you drive the car, the digital space will be manifested in the physical space, and then you have a problem. So this is the challenge people are facing with when management are telling them, there's money to be had in AI, we need to increase productivity by 15%, get some AI into the processes, put them into the products, and let's get on the AI bandwagon. And people say, whoa, yes, but I want to end up in that top right corner there, man. And on top of that, you have to deal with the things that that are just the nitty-gritty reality of the fact, and that is, today there is a tremendous amount of fragmented tool sets. And I'm sure you've seen these overviews of all these various ways of standing technology up. The workflows are complex. Also, there's a bunch of governance that you have to think about, compliance, and yes, the EU Act and everything, but even regardless of the compliance rules and regulations, you don't want your cars to be crashing your passengers. You want repeat customers, right? Also, there is a challenge now that how can you find a way of scaling with a small little first step and then try it out? Because you know there'll be dragons everywhere, right? You don't want to end up in one of those crashed pilots in the POC graveyard, but you don't want to put into production something that you don't understand or control. And then finally, once you have that in production, how are you going to manage it? And all of this builds up the complexity and hinders that acceleration of trustworthy AI. Also, you may be faced with, yes, let's just go the easy route and call a black box out there in public space over an API and have it do something for us, and we can just be fine. It's easy, yes, but you won't really be able to control it at all. Or you have to maybe go the open source route and stitch your own stack together, and then you're faced with the complexities of managing that stack. You have full control, but you also have a lot of pain. And this then is sort of the background of the context for what HPE and NVIDIA are doing together. So we've sort of both looked at this problem and said, okay, this is a problem. We need to figure out how to accelerate out of this. Like, what is the forward escape mechanism that can take us into the future more safely? And then we said, well, let's co-develop solutions. And let's try to see if we can work together here, because NVIDIA are good at certain stuff, HPE is good at different stuff. So how can we team together? And we said, well, let's see if we can co-develop a stack that makes acceleration possible. And we said, okay, let's do that. We'll call it NVIDIA AI Computing by HPE. And we will basically take infrastructure. And I mean, I guess most of you will associate NVIDIA with GPUs and maybe HPE with servers. So that's fine. Let's put those together. Let's put the software stack on place there. And yes, NVIDIA does a lot of really interesting software, as does HPE nowadays. I didn't know that a year ago when they called me and recruited me, but now I know, and you should know too, because there are some really sweet capabilities available there. And then we also stack the model or the model libraries or the openness to the repositories out there, like Hugging Face and others. And then we try to figure out a way to help you manage this so that if you want to get going, you can. And of course, we want some sort of control plane mechanism so that those that are accustomed to the cloud experience can have the same experience when they move into something slightly more complex, maybe. And this then we call the private cloud for AI. And basically what this is, it's a bundle, it's a pre-integrated set of software, hardware, put into an appliance. You could buy the appliance, you can roll out the box. If you have power enough in your socket, you can plug it in, and with 3-click deployment, off you go. And these come in different sizes, and you can certainly, consider your use case. But the idea is to make it possible for you to get access to something that accelerates your use of AI and sort of frog leaps a lot of these hurdles that you otherwise need to spend time on. And what you get basically is you get the stack and all the capabilities that you need to actually execute your full AI lifecycle. Everything from data load to model development to inferencing, and then circle back to the start, and then monitoring in production continuously. And you get that with what HPE traditionally has called the Green Lake offering, right? And this is basically our way of trying to replicate all the sweet benefits of the cloud experience, because they are truly sweet. They are really nice. And the great thing with going to the cloud is, of course, it's very easy to be there. So how do you maintain the same ease of use if your complex IT estate now is hybrid and you have certain things on-prem, you have certain things in the local data center, you maybe have a few things co-located, and now you've rolled in this appliance box that gets you going with AI. So how do you make that practically real? The benefit is also, if you do this, you get access to something that NVIDIA is pushing very hard. And I don't know if you listened to NVIDIA recently, but they focus very much on what they call the inference microservices, which is, again, a way of bundling complexities into stacks that are readily and easily deployable. And if you do that, and if you make use of their software and their use case specific or domain specific NIMS bundles, basically, you can see these accelerations of the throughput. And again, this is a way that we hope will accelerate your speed into the future, right? So rounding off, what we hope to achieve by sort of creating this offering, by co-engineering these solutions, by making it easy for you to apply them and use them, is one, we want to figure out a way to make you in control of your data, right? You're not in control of your data fully if it's outside of if you're on the cloud, basically. I mean, sure, the cloud providers will take responsibility for that data, and that will be the way you build trust. But if you want more control, maybe you want even an air gap solution, maybe you want to keep completely offline, you can still do so with this appliance. Also, we want to make it easier to take these steps from that first little tryout, because the use cases are there. There is no need to do proof of concepts anymore, I think, in a bunch of areas, but there is a challenge of moving things into production. And finally, once you're in production, how do you repeat and scale, and how do you make that easy? Well, one way of making it more easy is to take away the time you need to spend in managing the stack and just focus on what it is you actually want to achieve in terms of business impact of your AI use case. And finally, there will be a need to monitor these complexities over time. There will be more and more need to be able to understand how are the models behaving in production, and when they're veering off, when they're starting to drift, how do you retrain them easily? Or if you want to understand what is the environmental impact of running the inference or running some training, you need able to have transparency through your IT stack as well. So, in total, this is what I wanted to convey to you. We are present in the booth. If you want to dig into the details of how to make this real, or if you want to buy one of those appliances, call me. We will be over there. And with this, I think I say thank you.
Thanks very much, Patrick. I love that. Questions from the floor, please raise your hand. I was wondering about our tolerance level for mistakes in AI, right? So you talked about cars crashing.
Yeah.
And if we look at, when the first Tesla crashed, everyone went, oh, this technology is no good. And yet it had already, the Google test cars had already run 1 million miles without an incident, which just absolutely pulverized any human efforts, right? And I'm wondering, do we have and should we have higher expectations of excellence from AI, or should they just exceed what already exists in humans? For example, with Tesla, for example, should we readily accept that they're on our roads if year on year they kill people but less people than humans?
Yeah, and that's a great question. And it all depends upon your preference, discrete values or averages. And I think there are certain fallouts that we just don't accept. And I think the EU AI Act is sort of an attempt to sort of classify things and then make sure that we don't end up there.
Yeah.
So even though statistically it's probably correct that if you remove the driver from the car, you will decrease deaths in traffic by 90% or something.
Yeah.
It's only that you will still sort of kill off a bunch of people over the year, and that will be done by the machines or technology. And so how do you grief recover from that? And is that an acceptable fallout? And if not, okay, what is? And I think this will have to be use case based, like the tolerance and acceptance for the negative fallout.
Yeah.
In certain cases, it'll be okay, right? So you botched the customer interaction, you got an angry email, you won the customer back, and that's fine. And in total, it's good to have chatbots in customer care. But in other cases, maybe not. But,
Yeah.
But as a general principle, I think we should demand much more of our technology than of our kids or our fellow workers, right? I mean,
Yeah.
put pressure on technology.
Yeah. No, this huge potential there if we're willing to accept a small amount of error.
Oh, yeah.
Do we have questions from the floor? Any questions? No. Okay. Patrick Couch, thank you so much.
Thank you.
Well
Thank
done.
you.
Great talk.